Hey all, this is Derek and this is section 10.2, operations with algebraic fractions. So in this section we will look at multiplication, division, and addition and subtraction with fractions. I'm going to start with a little review of just regular old numerical fractions first, because the steps for these are the same thing as the step for the algebraic ones. So I just want to kind of remind you how these go with something a little more familiar before I do the more complicated ones. So for multiply, and a lot of times in school we're taught to go 5 times 21 and 9 times 10 and then have to reduce the big fraction, which is a terrible way to do it. A much better way to multiply is to factor and cancel. So 5 is 5. 9, I'm going to make 3 times 3, so I'm breaking it down to its primes. 21 is 3 times 7. And 10 is 2 times 5. So once I got that, now I can cancel out the 3's, I can cancel out those 5's, and I'm left with 7/6. And so if you notice, I really hardly multiplied at all. When I multiplied, I mostly factored and then canceled out 15 over 15. I could have done it the other way. I could have gone 105 over 90 and reduced, and I would have eventually got to 7/6. I just think it's easier to do that. This is also what we need to do in their algebra. So same basic idea here for divide. Remember when we're dividing fractions, the first thing we do is we flip the fraction. And then here, you know, if we're doing this, we'd probably just go 5 goes in twice. I'm just going to do it. 5 goes in twice. 2 times 2 would be 4, and then times 3. And I could have written that way, right? And then canceled the 5. But it's that same idea. I'm just kind of factoring the 10, canceling the common factor, and then multiplying what's left. For addition, this is, I'm going to show this a little bit differently than probably how you're used to seeing it, but it will be helpful for where we're going. So I'm going to factor these denominators. And so this is 2 times 3 would be the 6, 2 times 5 is the 10. And then what I got to do to get a common denominator, right, because to add fractions we have to have the same denominator so that we can add our numerators. So I'm just going to look at kind of what they're missing. This one has a 2 and a 3. This one has a 2 and a 5. So fractions are jealous and they want what the other one has. So since this one has 2's and 3's, it's jealous of this one's 5's. So we're going to do 5 over here. And then this one has a 2 and a 5, so it would be jealous of the 3. And once I do that, then we got 5 times 1 is 5, and this would be 10 times 3 is 30. And then right here we have 9 times 3 is 27, and 10 times 3 is 30. And then 5 plus 27 is going to be 32 over 30. And then, let's see, we can write that as, let's go 16 times 2, and then we'll make that one 15 times 2. Canceling, we get 16/15. So to recap on that, I factor my denominators, I figure out what each piece is missing so I can build the denominators up to the same value. And then once I have these the same, now I can add my numerators. We got that there. And then it may or may not reduce from this point on. This one happened to, so then I can factor and cancel just like we did in the last section. Okay, for this next example, they're algebraic fractions, but kind of the most simple ones possible. And again, it's just this idea of sort of getting straight what we do when we multiply, divide, what we do when we add, subtract. So this first one is 3 over d plus 7 over d, so that already has a common denominator, so that will just be d. And then we're saying 3 plus 7 would make 10. Likewise, subtraction, common denominator already, so just 3 minus 7, so that would be negative 4 over d. Multiplication, there is nothing I can reduce there, so we're just going to multiply straight across. 3 times 7 makes 21, d times d makes d squared. And then this last one here, 3 over d, we'll rewrite this as a multiply, so we take the reciprocal of the second fraction, and d over 7, and now I do have common factors of d, so that one reduces to 3/7. Okay, so now I have the same thing, but with real algebraic fractions. So these ones are where we're going to have to do a little bit of factoring probably, and then cancel. It's the same steps as what we just saw. They just look a little bit more complicated. For this one, let's rewrite this as 5c cubed. And then here there's this common factor 6. So I'm going to go 6c plus 2. And then times c plus 2 over c squared. So now we got c plus 2, c plus 2. Those cancel. And I think I could cancel right there, but I'm just going to group that up for a second to make it easier for you guys to see the next part that I cancel. So I had c squared down here. I'm just kind of putting that together. I hope you can see I got 3 c's up, 2 down. So if I cancel out 2 of those, I'll have 5c, 1 left up top, over 6. You could also write it as 5/6c. Those mean the exact same thing. Okay, this next one's division. So we'll go 14 over x plus 5, x minus 5. And division, so I'm going to do the reciprocal here. X plus 5 goes up top, 7 comes down. And now we can cancel out the plus 5s, and then 7 goes into 14 2 times, because again, we're kind of thinking of that as a 2 times a 7, and canceling out those 7s. So I think what's left up top is just the 2, and then x minus 5. Another division, a little bit more factoring on this one. So multiplies to 12, adds to be negative 4 would be, or adds to be negative 1 would be a negative 4, positive 3. Right there we get a common factor of 5, so we'll take that out front. Division, so reciprocal times x minus 4. And let's take a 5 out of those, so that's going to go 5x plus 3. And then let's see what we can get rid of. X minus 4's cancel, 5x plus 3's cancel. And it looks like we just have the x minus 4 from here, and then 5 times 5 for 25. Okay, for this one, again, factor cancel. So multiplies to negative 15 and adds to be negative 2 will be x minus 5 and x plus 3. That's prime, so it just stays as is. 3x plus 3, so we take a 3 out front, x plus 1. And then multiplies to 5 and adds to negative 6 will be an x minus 1 and x minus 5. So we can get rid of the minus 5s and the plus 1s, and I think that's it. So then 3x plus 3 over x minus 1. Okay, so next up is adding and subtracting. And first we'll just find a couple of LCDs, and you'll see on the homework you'll have 2 boxes. One where it says find the LCD, put that in the box, and then find add or subtract as directed. I think the LCD, they have you do that so that if that's wrong, you at least know that's where the error is, so that you can go back and find it. Anyhow, so here's a few examples of just finding the LCD, and I'll do with full-fledged addition and subtraction. So looking at 6x and 3x squared, if I think of that 6 as 2 times 3x, and I think of that 3x squared as 3 times x, and again, I think I'm sort of being jealous. The 6, the 3 goes into the 6, so my LCD is going to have the 2 and the 3 in it. And then this one has 1x, this one has 2 x's, so this would end up needing 1 more x eventually. So my LCD is going to be 6x squared, where this one gets an x and this one gets a 2. And that's the smallest I can make that. For these two, if you just notice that this one right here, if I take a 2 out front, I get 3x minus y, which is this one with a 2. And so that would be the LCD. This would end up needing a 2 if I were trying to add those, for instance. And then with these two, they're both prime. There's nothing I can do. It's like having 1/3 and 1/5. All you can do is multiply them together and get 15. Here, all you can do is multiply them together, and it's x plus 3. And that'd be the LCD on that one. Okay, then for adding and subtracting, so our steps are find the lowest common denominator, and then build each fraction to an equivalent one with the LCD as a denominator. So that's where I was sort of building them each up to have the same denominator, the last examples. Add or subtract the resulting like fractions, so we can add the numerators once the denominators are the same, and then reduce if necessary. So this one, x minus 5, it already has a common denominator, so that means I can just think of this as x squared plus 25 minus 10x all over x minus 5. So the same as if I had, 3/5 minus 1/5, I could just write that as 3 minus 1/5 or 2/5. That's what I'm doing here. Let me write that in descending order, and then we can see that it's going to reduce a little bit. So once I get there, then I can see, okay, I can factor that numerator a little bit. It's going to be x minus 5. You could write it squared or just write it side by side. And then that allows me to cancel out one of those x minus 5s. Okay, so for this example, we don't have a common denominator. They both have x's, so that's good. 12 I would think of as a 2 times 6. 10 I would think of as a 2 times 5. And so that means that the 12 is going to need the 5, and the 10 is going to need the 6. So my LCD will be 60x. So over here we'll do this 6 over 6. And then for that fraction, we'll do this one by 5 over 5. And then I think I'm going to rewrite this so you can kind of halfway read it. I'm going to move the 6 in front just because it looks better for doing the distribute. And then my denominators are 60x, so now I can just write that as the common denominator. So now I have that looking a little bit better. There's a lot of errors that go from here to here when people kind of try to do that step. So writing it out good can help. Let me go ahead and clean this up. So 5 times 3 would be 15x plus 25, 6x plus 24 over 60x. And then collecting my like terms, I got 15 and 6 there, so that's 21x. 25 and 24 would be 49 over 60x. And it just occurred to me someone might want to factor a 7 out of there. You could, but it doesn't cancel with that 60 at all, so there's no reason to. So I wouldn't. It's good to look and see if it does. If you could factor and cancel, you would need to. But in this case, it doesn't reduce. Okay, so for this example, x and x minus 2 are both prime. So all I can do is multiply them by each other. So this one's going to need the x's, and then this one's going to need x minus 2's. So let me write that out a little bit better. So this will look like 5 times x minus 2 minus 2 times x. And that's all over x minus 2. Careful not to cancel there. That's subtraction. Remember, we cannot cancel when we have subtraction going on. If that was times, we could, but it's not. So instead, we'll distribute 5x. 5 times 2 will make a minus 10 minus 2x over x minus 2. And then 5x minus 2x, that gets us to 3x minus 10. Notice there's no common factor there, so I'm not going to be able to reduce x minus 2. Okay, and this last one, again, nope, nothing common between the denominators, so all I can do is multiply them together. They're both prime, so this side gets the minus 1s, this side's going to get the y plus 1s. And then they'll both have plus 1 minus 1. Let me write that out a little bit better. So 2y plus 1 plus 3y, y minus 1 over y plus 1 and y minus 1. And again, careful to not try to cancel that stuff. That's an addition problem. It'd be, I'm actually not going to go there, but remember, we cannot cancel across addition. So simplifying, we'll get 2y plus 2 plus 3y squared minus 3y. And y plus 1 and y minus 1. And then that numerator is a little bit of a mess. But 3y squared, 2y minus 3y, that'll leave a y, and then plus 2. And that's over y plus 1 and y minus 1.